Hello guys, welcome to Code Enzyme, and in this video we are going to discuss the problem 1834 of Leetcode, the single threaded CPU. And in this playlist I discuss daily the Leetcode problems. So let's see the problem statement. You are given n tasks labeled from 0 to n-1, which are represented by a 2D integer array where task I is enqueue time and process time. It means that the ith task will be available at process time enqueue time, and it will take process time to finish the processing. You have a single threaded CPU that can at most process one task at a time, and it will work in the following way. You can read it. I think the main line is this: if the CPU is idle and there are available tasks, the CPU will choose the one with the shortest processing time. If there are multiple tasks with the same shortest time, it will choose the task with the smallest index. Okay, so this is the catch here. And once a task is started, it will process the entire task without stopping. So let's see this with an example. Since we have at time t equal to 1, task 0 is available to process, so it will take this task. And then we can either take task 2 or task 3. Since task 3 has the we can either take task to this one 3,2 or 2,4, since this has the smallest task process time, so it will take this one. And after this finishes, we can either take this one and this one, because the time overlaps is 5, so we can take time equal to 4 or time t equal to 2. So we will take 4,1, and next this is left, so we are going to take this. Okay, so we need some way to find in big O of 1 the smallest possible time that is at hand. And what kind of data structure will help us do that? It will be a heap, right? Because it stores a min heap will always store the shortest index at the 0th at the tree head. Okay, so let's see how we can do that. So first I'm going to make a heap out of my tasks, and you can see that I have this I'm also storing the index. So I updated my tasks, and I am storing this index also in my array. And when I convert it into a heap, it should look something like this. And I have sorted it using the 0th index. So this 0th index are in ascending order. Okay. Now and I have two more heaps. This waiting is also a heap, and currently the time is 0 and our final answer is empty. Now when I choose my first task, since my waiting list is empty, I am going to choose from the heap. Okay, so this was the first task and I have chosen that task. And now my time at time t equal to 1, I chose that, and it took time 2 seconds to complete. So my time is 3 right now. And when I check in the heap, now I am going to search this entire heap, and I am going to check which all tasks have starting time less than 3 or less than or equal to 3. So these two tasks were in this main heap, and I am going to transfer them to the waiting list now. So my waiting list has become 3, 2, and 2, 4, 1. Why this array? Why this order? Because now I am sorting them with the finish time, the process time, because I have to choose the smallest process time now. And my answer will become the answer will have the 0th index, and I have removed these two tasks from the heap, so heap only has this one task now. Okay, now when I will choose the second task, I can see that my waiting list is not empty, so I am going to choose from it. Now since this was my first task in the waiting list, this is my current task, and my answer I am going to append this 2 in my answer array. And now my time is equal to 5, because it took 2 seconds to finish it, so my time has become 5. Now I'm also going to traverse in my heap, and I'm going to check how many tasks have a starting time less than or equal to 5. So there was one task, so my heap has become empty, and this task was appended to my waiting list, and final heap will be this, because we have sorted it with the finish time, the process time. Okay, and the third task will also be the same. We will choose this 4, 3, and we will append this 3 here, and last time it was 5, so I'm going to add this 1 to my time, so time has become 6. and now in my waiting array we only have waiting heap, we only have one task, and like that we can choose the 4 task. And now since waiting and heap both are empty, I'm going to stop here, and this is my final answer. Okay, so I hope I was able to explain you the at least the implementation part properly. Now let's see the code. So this is a Python code. First we have a heap, and now I'm going to use the enumerate function in Python to get the indexes, and I'm going to push them into my heap. And I have a waiting heap and an answer array. So if I have something in a waiting I'm going to choose f and I from I'm going to talk about why I have put this like that here. And if not, I'm going to choose from heap the start time, the process time, and the index, and I will set my finish time as e. Okay, now I'm going to add this finish to my finish time because it took that much time to complete. And now I'm going to traverse the heap till this is less than or equal to finish time, and I'm pushing this f comma I to my waiting list. Why? Because in Python I was not able to find the sorting. If it was possible to sort it using the second index, I mean there were ways, but not with the heap. Okay, not with this heap push function. So I just decided to remove this first index, and since and this will be able to sort it using the finish time. Okay, and after that I can just return the answer. And if you are running this on your computer, you can just put this print statement here. You will be able to see how your heap is changing, how your answer and waiting heap and answer is changing, and you should be able to get that idea. Okay, so this was it, and I hope I was able to explain it properly. So if you were able to understand this question properly, I hope you like this video. Subscribe to my channel. So thanks for watching. I will see you guys next time with another problem. Thank you.